Hello guys, and welcome back. Last time we left off with adding and subtracting complex numbers. We also learned that imaginary numbers are represented by the variable I and can be treated much like any other variable. Additionally, we learned that I has an actual known value, the square root of -1. So, what's after addition and subtraction? Obviously, in today's lesson, we're going to talk about multiplication and division. Now, when we multiply imaginary numbers, we treat them with the same rules we have for variables. The only difference is we must evaluate if the I term can be simplified to one of the values listed in the chart. Notice I to the first and fifth powers have equivalent values, and I to the second and sixth powers are also the same. Okay? Since I to the fourth power is equal to 1, and anything times 1 is itself, we can evaluate the value of any I term by dividing the exponent by 4. Any remainder then allows us to find out what I is. If the remainder is 1, the value is I, and if the remainder is 2, the value is -1. This makes sense because if we square the square root of -1, the root of the exponent cancel each other out, and we're left with what was inside the square root symbol, right? And so on. If the remainder is 3, the value is -I, and if the remainder is 4, then the value is 1. And this means real numbers multiply by other coefficients as well, not unlike algebra. So if I have 5i times 6i, I will have 5 times 6 times I squared, which will give me 30 times -1, since I squared is -1, if we refer back to our chart there. Therefore, we'll end up with -30. Let's try an example problem together. What is the value of 5 square root -25 times 3 square root -64? So what we do here is we have to first simplify this expression. So what's the value of square root -25 and the value of square root -64? After simplifying, we end up with 25i times 24i. We multiply, keeping in mind we will need to evaluate the I term later because it will end up having an exponent, such as 600 times I squared. I squared is equal to -1, so 600 times -1 is -600. Now, how about we try one for division now? So if we have 6i cubed divided by 3i squared, this one is actually pretty simple to solve. We divide 6 by 3 first to end up with 2, obviously. And next we have to divide the I to the third by the I to the second. And of course, the rule of exponents say that we can just simply subtract the exponents if the bases are the same, right? So we're left with 2 times I, and then you take the 3 minus 2, which is left with 1. So it gives us 2i, right? Because I to the 1 is I. Multiplying with complex numbers. Do you remember what we went over last class about complex numbers and what format they're in?
I remember. It's in an a plus bi form.
Yes, that's correct. When we multiply complex numbers, the rules are a lot of multiplying binomials using the distributive property. The mnemonic foil may help you remember how to do this. Just remember to evaluate and simplify our I terms at the end. Let's take a look together at an example problem. 2 plus 5i times 4 plus 3i. Now, how do we solve a problem like this one? Well, similar to polynomials, anytime we have two binomials being multiplied together, we have to distribute the binomial through the second one. You might remember the mnemonic FOIL, first, outer, inner, last. And we end up with 8 plus 6i plus 20i plus 15i squared. Now, let's evaluate 15i squared. Since I squared is equal to negative 1, and the last term ends up simplifying to negative 15, and then we kind of have to add up the like terms, right? So we have 8 minus 15 plus 6i plus 20i. So our final answer in the standard a plus bi form is negative 7 plus 26i. So as you can see, multiplying and dividing imaginary numbers is not too difficult on the SAT. But no worries, we'll go over some additional sample problems in our very next lesson.